But long story short, two main things we're going to be working on today. Our foundations, how to make sure we can add, subtract, multiply, and divide without hesitation, the general way. Even if it takes us a while, even if it takes us a minute or two, we still know absolutely how to do it no matter what. And once we get to that point, we're going to practice for speed. So that's the main number one point we're going to be working on today. Number two, building your confidence. So everybody, my party people, help me out here. True or false? There is only one way to do a math problem. True or false? Yeah, that is a big fat false, right? Yes, that is false. So remember, guys, there's never only one way to do a math problem. You know, I could have you say, hey, man, count to 10. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10, 5, 10, 7 plus 3. There's a million different ways that you can express the same thing in math. Math is a language. There's a million different ways to say the same thing. So the reason I'm saying that is because even the most generalized things like adding, subtracting, multiplying, dividing fractions, each of those might have a bit of a shortcut that you could take advantage of. Remember that shortcuts are all about saving time. If you like saving time, if you like giving yourself as much time as possible to try this problem out, as opposed to having a minute left on the test and thinking, oh man, I got 10 questions left. I got to guess on everything. I'm not going to ask you if you've been there before because I already feel you guys shaking your heads. So with that, we have to make sure we emphasize and prioritize optimizing what we're doing. Yeah, we can be good at this, but how can we be better? So that's what we're working on today. So we're going to go ahead and get started here. We're going to play a little game. I'm going to go ahead, give you these questions just like this, and I'm going to put a little timer right next to me, right over here. Give me 2 seconds to show the timer. And I'm going to give you just a little bit of time, like not even that much time. It's going to be very quick. Perfecto there. I'm going to put this right over here. And it's going to be very quick. I'm going to give you maybe 20 seconds at a time. Not even, maybe 10 seconds at a time. And I want you to go ahead and see if you can spot the answer right away. We're going to go through all of them. Then we're going to come back around and actually talk about what we're seeing on the screen. So let me go ahead and put this up right here. There's my timer. And I'm going to give you 12 seconds at a time. 10 seconds is what you're going to see, but it'll be 12 total seconds. So, okay, cool. So you've given your answer there. You think it's B, to add or subtract fractions. Fractions need to have the same denominator. That's correct. We'll come back and talk about that in a moment. But let's go ahead and start the timer for the next one. Go ahead. Can we add or subtract the following fractions here? 1/3 plus 5/3. Go ahead. Give your answers. Give your answers. Give your answers. So we're going to just wake ourselves up. We're going to see how much of this we remember, how much of this we know. Let's go ahead and try the next one out. We're going to come back to the answers in a moment here. 3, 2, and 1. Let's try this next one out. That's a repeat, excuse me. Go ahead here. Can we add these? Can we add these? And time's up. So for this one, can we add or subtract them? Okay. Y'all say no. Answer's no. Not quite yet. Let's try the next one out. We'll talk about the reasons in a bit. 3, 2, 1. Let's try this next one. Can we add these? 10 over 12 plus 6 over 8. Can we add those? Can we add those? Time's up. What do we know? D again. Saying no, the denominators are not the same. Again, that's going to be correct. We'll come back and talk about this in a moment. What about this one? A proper fraction is where what? Timer started. Go. All right, what are those answers? What do we have? Look at that. The answers are finally a little different, right? It looks like all of us were pretty much on the same page when it came to understanding that one basic rule. Hey, if you're adding and subtracting fractions, you need the same denominator. Y'all knew that. Y'all had that down. Now, if we're taking a look at something a little more nuanced, a little more detail specific, what's a proper fraction? Looks like we have some differing answers, but the right answer here, if you want to see it right now, it's going to be the numerator is less than the denominator. Let's go ahead and look at the next one here. 3, 2, and 1. What's this one? Y'all have heard of this one before, a lot more than you've heard of a proper fraction. What's this one going to be? Yep, that's going to be A, correct. An improper fraction is where the numerator, the top, is bigger than the denominator or the bottom. Okay, let's try another one out. 3, 2, 1. Let's try this one out. What's this? You've heard of this one before. 3, 2, and 1. All right, looks like you guys are alive and awake. Yes, that's going to be C. The whole number is attached to the fraction. So essentially what that looks like right over here is going to be something like 3.5. You know, we've seen that before. Definitely seen that before. That's what a mixed number would look like, where you just have a whole number and a fraction together. Basically, it's representing a decimal value that's greater than 1. So next one here, I think we have one more. Yep, we do have one more. Let's go ahead and get this one in 3. There you go. 2, 1. Next up. So when multiplying fractions, you should what? And time's up. What do we have? When multiplying fractions, you should what? Make sure the denominators are the same. Multiply the numerators, but add the denominators. Keep the first fraction the same. Change from multiplication to division. This sounds like a bunch of hoo-ha, but these all sound pretty familiar too. The answer here, though, is going to be A. When you're multiplying fractions, just multiply across, or multiply straight through. Numerators with numerators, denominators with denominators, and that's it. Let's go and get this next one here. 3, 2, and 1. Go. How about when dividing? 3, 2, and 1. When dividing fractions, you should what? B. That's right. Keep the first fraction the same. Change from multiplication to division. And then flip. Take the reciprocal. Again, we'll talk about this in a moment. I got you. We're going to take all of these notes. Let me just make sure that we are getting through all of these with due time, because I want as much time to practice and really get into those notes. So here we go. Another one. Last one. 3, 2, and 1. Also for the private message here, Diop. I know it's been a while. You haven't attended classes. You were overseas, but just wanted to thank you and say how good your classes are beneficial to whoever is reading this. You guys are good in good hands with Coach Anderson. Hey, congrats on wait, you passed? Let me just double check, because I think I might have missed your message too earlier. I think I saw one. Yeah, you passed. Right on. Diop, congratulations. Hey, congratulations, my man. Go ahead. Reach out to me. Text me if you haven't already. Man, congratulations. Let's go. Let me know what score you got. Yeah, thank you. Yeah, he's messaged me privately, so you guys might not see it. But, hey, congratulations. Let's go. It's good to see you. I'll always stop class for those. Appreciate you guys being patient. Congratulations. And no worries, Josephine, I got you. We're going to really get into it. And if you're using your phone, just turn it sideways. It'll be a lot better. So with that, cool. So we're good. So let's go ahead and go back up here and just review them start to finish really, really briefly. I got your back. So long story short, everybody, in case you haven't had the chance to write these notes down, I got you. First things first, adding and subtracting fractions. What you need to know is this. You need the same denominator. That's really it. When you think of denominators, think about the way that a box of pizza is sliced. If you have different denominators, it basically means your slices are different sizes. If you try to take a slice from one box and put it into another, it's not really going to look very good. It's not going to look very clean or symmetrical, because if they're cut different ways, you're going to be able to tell which piece of pizza is the odd man out. So basically, again, the denominators right here, if you're looking at, let's say, 1/2, which looks like this, and then 1/3, which looks kind of like this, you're going to be able to see that, yeah, if these were slices of pizza, these slices are very different sizes. We can't have that. We need the same size of the slices to be able to swap them between boxes. That's the very simple explanation that I like to use when it comes to adding and subtracting fractions. We need the same denominator. The slices need to be the same size. Everybody good on that? Let me know if you're ready to move forward to the next piece of note. Gonzalo? Good. This might be the first class where we get to the practice before the 6:40 mark. That's what I'm trying to do today. All right, cool. So number two is going to be, after we take a look at that, blah, blah, we're going to get into proper fraction. So if you don't know what a proper fraction is, basically, here's the example. If you're looking at a fraction that isn't basically overfilled, if it's overfilled, it's not proper anymore. So a proper fraction is a fraction basically where it's less than 1. So if you're looking at, let's say, 2/3, that's a good fraction. That's a proper fraction. If you're looking at, let's say, 5/8, that works. 9/10, that works. 10/17, that works. What doesn't work, somebody give me an example in the chat box. What's an example of an improper fraction? What's an example of an improper fraction? Yes, 17/10, 20/10, 3/2. These are all going to be improper. 15/4, 8/5. Long story short, if the top is bigger than the bottom, it is improper. If the top is smaller than the bottom, it's proper. It works out just fine. And if you think about it, if you want to remember the difference between them, if I say, let's go ahead and look at 17/10. I got a box of pizza. I got 17 out of 10 slices left. The only way that would work, having 17 slices in a box of pizza that can only hold 10, is if you stacked the pizzas on top of each other. And at that point, that's not a pizza anymore. That's a calzone. So therefore, you don't have pizza. So if you think about it that way, you can kind of make a little more sense in terms of, hey, proper fractions and improper fractions. If you have less than the whole, that's proper because you can fit it in a box. Does that make a little more sense, everybody? We don't want calzones. We like pizza. Cool. Sounds good. And if anybody here lives in Chicago and you call deep dish pizza, fight me. You don't belong here. Cool. Next. So with that, I'm going to make some haters today. So with that, let's go ahead and move on to the next one here. We just looked at improper, just like we did. But now let's look at a mixed number fairly quickly. Kai, you got offended. You're one of my favorite students. Cry about it. So here we go. A mixed number. Again, it's just basically a whole number and a fraction next to it. So this is pretty straightforward. So if we have, again, like I said, 3.5, if we have 4 1/7, 10 and let's say 7/15, all of these are mixed numbers. You're just mixing a whole number and a fraction together. Just know that the fraction has to be a proper fraction. You can't say 2 5/2. That just doesn't make sense to me at all in terms of the readability, being able to just read it and understand what it looks like. For example, everybody, if I said 2.5, I think y'all can imagine 1 block, 2 blocks, and then maybe half a block. But if I were to say, 3 and 10/3, okay, 1, 2, 3. But then the 10/3 is improper. That's overfilled. It's a lot harder to visualize what you're talking about. So that's pretty much it. I don't want to overcomplicate things. Mixed numbers, you just have to make it proper. A proper mixed number is a whole number in a proper fraction. Everybody, yes or no? Are we good to move forward? Cool. All right. So with that, let's go ahead and again keep the party going. We have to really get into these foundational pieces. So if you didn't write this down yet, or if you didn't know this like the back of your hand, I highly suggest you write this next one down, just like I have been telling you this whole time. So when you're multiplying fractions, this is the general rule. The general rule is multiply the numerators, multiply the denominators. I'm going to show you an example of what this looks like right over here. Let me give you enough space. I'm going to use this space, that white space right there. But let me take off the timer so you can keep writing. Cool. Here's an example. Let's say we have something like, let's go ahead and say 4/5 multiplied by, and then let's go ahead and say 7/8. Something of that sort, right? Now, what this means, when it says multiply the numerators right here in red, all that means is, hey, we're going to take these two and multiply them. Everybody, 4 times 7 is going to be what? Appreciate you, Indy. So, yep, that's going to be 28. And then in the denominator, let me just highlight that right there. In the denominator, we're going to go ahead and multiply that. So we're going to have 5 times 8. Everybody, 5 times 8, that's going to be what? Cool. That's it. That's really, really, really it. When you're multiplying fractions, let me highlight that for you. I got you. When you're multiplying fractions, you're going to multiply the tops, multiply the bottoms. This is not the same as a proportion. Has anybody here mistakenly taken that rule and looked at something like this? Like, x over 10 equals 5 over 13 or something like that, and you tried to multiply across. No, this is not what we're talking about. This is not. That's an equation. That is a proportion. This is clearly multiplying right there. Here, that's an equal sign. This is not where that works. Here, you would cross multiply. Exactly, Lewis. Here, you would cross multiply. When you're actually being told to multiply, that's the rule. Numerator times numerator, denominator times denominator. But my party people, there's one thing that we kind of left out, and Indy already pointed it out. When it comes to dealing with fractions, everybody, at the end of the problem, typically we have to make sure that we did what? That the fraction is in what terms? Yeah, we got to make sure that we simplify, and we have to make sure that it's in simplest terms. All it means, and if you've ever been confused on what simplest terms means, simplest terms just means that the numerator and denominator no longer share something that they can both be divided by. So for example, if we're looking at 28 over 40, well, everybody, guess what? 28 is an even number, 40 is an even number. What does that guarantee that can be divided into both numbers? 2. You can guarantee if you have an even number in both the top and the bottom, you can always simplify it because they're both divisible by 2. But everyone, should you always go for the smallest number to try to simplify first? Should you always try to go for the smallest? So that answer, you could say no, you could say yes. You would be correct in both. My preferred answer is no. My preferred answer is no. The reason that it's going to make it definitively no is because you're being timed on the ASVAB. And the answer choices that are given to you, if it's fractions, will always be in simplest terms. Always. Guaranteed. I promise you. So if we're taking it from that perspective, then yeah, you need to make sure that you use the biggest number that you can divide out of both of them. Because if you can find the biggest number you can divide out of both of them, you're done automatically. Here's the example. Everyone, let's go ahead and say we went with dividing by 2, just to kind of say that we did it. So just to say that we did it, let's go ahead and start here. 28 over 40. And let's say we divided by 2 on the top and the bottom. So let's take purple here. Now, 28 divided by 2, that's going to be 14. 14 divided by 2, that'll be 20. Everybody, is this in simplest terms now? No, it still isn't in simplest terms. So we can take this x. Nope, not in simplest terms. Okay, let's go ahead and get rid of you. All right, well, 14 over 20, what else can we divide by? No, we're here. We're looking at the 14 divided by 20. I'm not going to start over. Where can we keep going with this? Where can we keep going? What else can we divide out? Yeah, just 2. 14 and 20 can both be divided by 2. You try 4, 14 can't be divided by 4. 14 is just 2 times 7. So technically, you can't do that to the top. Hopefully, that makes a little bit of sense there. The 20, yeah, you can divide 4 out, but the 14, you can't. So here, take it nice and slow. Divide out another 2. And that's going to give us 7 over 10. 7 over 10. And that's going to be the final answer. But notice the work that we did. We did, hey, divide by 2 right there, divide by 2 right here, and then we got ourselves our final answer. But everybody, what's the biggest number that can go into 28 and 40? Thank you, Indy, Lewis, Zaro, Jocelyn. Yep. Yeah, it's going to be 4. 4 times 7 is 28. 4 times 10 is 40. So we can try dividing out the 4. 28 divided by 4, everyone, will be what? That's going to be 7. And 10 or 40 divided by 4, I gave away the answer. 40 divided by 4, that's going to be 10. So here's the point I'm trying to make. This long-winded example, all I want you to understand and take away from this is when you're simplifying fractions, make sure to try to find the biggest number that divides to both the numerator and denominator. When you find that biggest number, you take literally one step to simplify instead of risking wasting time trying to finally simplify. Does that make any sense, everybody? Yes or no? Cool. And now there is a shortcut that I'm going to show you. It's really just the same process, just backwards. You saw that what we did was first multiply, then simplify. Well, here, I'm going to show you eventually, as class goes on, that you can actually simplify before you multiply. And if you do that, you're guaranteed that your final answer is already simplified. Or if you have to keep simplifying, it's going to be the easiest thing in the world. It's going to be a lot easier than before. We'll get into that. But for now, we are going to move forward into the section on dividing fractions. Everyone, what's the 3-letter thingy for dividing fractions? That's right, Jocelyn. And yes, for those of you saying KFC, I hope you're talking about Korean fried chicken. That is banger. But we're talking about KCF. We're talking about keep, change, flip. When it comes to dividing fractions, keep, change, flip is what we are talking about now, right here. So dividing fractions, keep, change, flip. Make sure to write this whole thing out. Let me just go ahead and give you this all together. There we go. But I'm going to try to zoom in if I can. If not, and if not, I got myself hungry too, I know. But if not, I'm going to make sure to write this down and repeat it as many times as I can, okay? So when you are dividing fractions, here is the rule. Keep the first fraction, change the operation, flip the second fraction. Do those 3 things, or 2 things, because you're not doing anything to the first one. But follow that process and then multiply. So dividing fractions, you have to do a little bit of voodoo, and then you actually get to multiply. So as an example, I'll show you here. And actually, I will give us a blank page. That'll be a lot better for us. Trust me. So let me show you an example of keep, change, flip for dividing fractions. So here we go. Let me go ahead and zoom on in. There we go. All right, so let's try the example. Let's go ahead and say we have 4 over 7 divided by, and let's go ahead and say 1/3. So here's how this works, everybody. Keep, change, flip. You see that there's 3 things going on here. 1, 2, 3. Keep, change, flip. So first things first, we are going to keep the first fraction. We are going to change the operation from division to multiplication. And then we're going to flip the other fraction. And so this right here will get flipped. And that'll be 3 over 1. That's it. That's all it does. And so then it sets you up with a multiplication problem. You do that and you're good. Does that make sense in terms of the 3-step process? Keep, change, flip. And I'm sure a lot of us have heard of this before, but just want to make sure that I am explicit in the way that I explain. Sounds good. Good with me. All right. So with that, from there again, you just perform the same things that you do for multiplying fractions. So here it'd be 4 times 3, that's 12. Then you would have 7 times 1, that's 7. And then from there, you're good. But everybody, pop quiz, what kind of fraction is that? Thank you, iPhone. Thank you, Kai. That is improper. Fiona, thank you. Perfect. So yes, that is improper. So my next question is, what do we need to turn that into if the question asks for it? What's that type of number that we could turn this into? Yeah, we could turn this into a mixed number. We could. Let me go ahead and explain how you would do that. That way you have it down. So number one. So improper to mixed number. Write this down if you need to. So here's how you would get this done. To do an improper or to convert an improper to a mixed number, step one, divide. Divide the numerator by the denominator. Okay? Step number one, divide the numerator by the denominator. Step two, well, you're probably going to get a remainder. If you get a remainder, that's the new numerator. So here we go. Let me write this down for you. So the result is the whole number. Remainder remains in the numerator. So let me go ahead and let you write that down with my jagged writing. So there we go. So you're going to divide the numerator by denominator. The result that you get, that's the new whole number. Whatever you get as the remainder, well, that remainder is going to remain in the numerator. So I'll give you a few moments to write that down, and I'm going to show you exactly how this right here, the 12 over 7, is going to fit that description. So let me go ahead and just take this over here. And then we'll go ahead and turn this over here. So everybody, first of all, you tell me, 12 over 7, if I'm trying to turn that into a mixed number, is that supposed to look like this or like this? Which one is it? Method number 1 or method number 2? Which one is it? Cool. I want to make sure because I saw a couple of people make the mistake. So I'm glad I did this. I'm glad we have a chance to not make this mistake too often. So it's going to be the second one. This is the correct one right here. This is the correct one. You're dividing the top by the bottom. The number on the bottom is what you're dividing by. We know that when we do long division, what you're dividing by is right there. It's on the outside of the box. You're trying to divide it into the other one. Okay? So hopefully that makes a little more sense. Let me erase all of this. And now let's actually do it. Everyone, 7 goes into 12 how many times? Right, 7 goes into 12 just once. It just goes in there one time. So we have 1. And then the way that we do long division is we're going to subtract by what that was. So 1 times 7 is 7. So I would subtract 7. And everybody, what's the remainder that I have? The remainder I have is 5. So let me highlight everything for you. So the result is the whole number. That's right there. The remainder remains in the numerator. So that 5 right there. Let me get rid of all this green. That way you can take a nice proper picture. But that's it right there. So this would turn into 1. Let me use a different color here. Just do 1 and 5 over 12. That remainder remains in the numerator. The result was the whole number. Does that make a little more sense to anybody out there? Converting an improper number to a mixed fraction or a mixed fraction. Or excuse me, over 7. What am I doing? I was so focused on the 1 and the 5 that I didn't even care about the 7. That's funny. Good catch. Yeah, that'd be 1 and 5/7. Who did that? I appreciate you for catching my mistake. Thank you, Andy. Appreciate that. Cool. So with that, again, main focus here, if you're not a Dumbo like me, main focus is when you divide, again, the top by the bottom, that whole number that you get, that's going to be the whole number there. And the remainder remains in the numerator, same denominator. Yeah, sorry about that, Yvonne. That's on me. That's totally on me. But yeah, hopefully we won't make too many of those mistakes. Cool. So looks like we are all set to move forward with dividing. Yes, you can turn mixed numbers back into improper fractions. With that, Juan, the way that we got the whole number was when we divided 7 into 12, 7 can only go into 12 one time. It can only go in there one time. And then from there, that remainder that we got, that 5, that's the 5 right there. Free shirt to Indy. Everybody, should I give Indy a free shirt? Yes or no? A free Ace the ASVAB shirt. That's not enough yeses. It's only like 30 people. Come on, man. Should Indy get a shirt? I'm kidding. Indy, you got it. Yeah, hoodie or shirt of your choice. I got you. Just feel free to shoot me a text. You have my number. I have your contact number saved. I got you. Look at that. You guys are a mob. You protested. You got it. Cool. This is how modern politics should work. So with that, moving on, let's go ahead here and move forward. And now what we're going to do, if Dominic was here seeing that, he would have flipped. But with that, what we're going to do now is we're going to get into the practice. We're going to get into adding, subtracting, multiplying, dividing. I'm going to guide you through it. And then we're going to get into a portion of the class where we're going to time ourselves in practicing these ideas and making sure we have it down. So this is really the part of class that it's way too important to try your best. Like, I know it sounds like cliche and motivational. Oh, just do your best. Like, what I really mean is make sure that you are being intentional about every move you make. That way you can clearly recognize when there's a gap in your confidence. Because when there's a gap in your confidence, that's the exact moment that you want to pay attention to and say, okay, I understood how to add the fractions, but when they have different denominators, that's when I freeze up. Or when the answer is a mixed number and I have an improper fraction, I freeze up. And that's literally going to tell you what you need to work on. That's why we spent so much time talking about the terminology. Because if we talk about the terminology, you're more equipped to understand what your issues might be. Yes or no? Does that make sense? Cool. Like that's one of the, I always say it's one of the biggest things because all of these ideas put together in terms of how you study and how aware you are of your studying, this makes all the difference in the world. So build your foundations like we did. That way, when we move into practice over here, we're going to be able to identify what our issues are. Everybody, first question, can we do whatever it is we need to do right away? Or is there a rule that we have to recognize? All right, there's a rule we have to recognize. All right, what's the rule? What do we need to be able to do whatever the heck it is we need to do? Yeah, we need the same denominator. Now, let me be clear. Let me help you be clear to yourself. Question, what other operations does that apply to? Because I see that we're adding here. What other operations does needing the same denominator apply to? Does it also apply to dividing, subtracting, multiplying? So, no, you don't need it for multiplication. It's just addition and subtraction. So let's go ahead and again, just refresh and keep making that clear. Thank you for trying your best. That's a ton of participation there. I love that. So now let's learn from it. So the same denominator is needed for addition and subtraction only. So same denominator is needed for addition and subtraction only. Make sure to write that down. Then say it to yourself once or twice. That way, again, we can recognize that if we are doing multiplication, we don't need to go by those same rules. So it's only addition and subtraction. Those are the only two you need the same denominator for. So with that said, let's see how we're going to do this. We haven't practiced this yet, but there's another rule. And again, these are basic fundamental rules that you need to know, but there's a fundamental rule that's going to really help us out here. Everyone, what's the rule for fractions? It has something to do with the numerator and denominator and doing things to them. What is that rule going to be? Who knows what I'm trying to say? I gave you a big hint there. Who knows what I'm trying to say? It's like simplifying, Landa. It's absolutely like simplifying, but maybe I wasn't clear. So to find a common denominator, what you're going to do is you're going to find what number each denominator can both go into. But to get there, once you figure out what that same denominator is, here's what you do. You're going to do the same thing to the numerator and denominator of the fraction to get to that denominator. So let me explain what that means. First off, it's this. Let me zoom on in. We have 6 over 11 plus 3 over 2. We already said, hey, man, we don't have the same denominator. Because we don't have the same denominator, can't exactly add them right away. So what we will do is we're going to find out what that same denominator is. What the same or common denominator is the same thing as the least common multiple. If you're unsure, you can always just multiply the denominators together. But what the multiples are for 11, 22, 33, 44, etc. And then for 2, 4, 6, 8, who do we appreciate? 10, 12, 14, 16, 18, 20, and then 22. This is the worst way to do it by hand, but I hope you can see that in those lists of numbers, 22 appears for both of those lists. Does everybody see that? 22 indeed does appear for both of those lists. Now we can keep going because 2 can go into 44. You keep going, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44. You could do 44, but if you want to try to keep your answer in simplest terms at the end, it's best to always use the lowest number that'll get there. So with that, let that sink in for a moment. I'm going to divert our attention back to here. Do the same thing to the numerator and denominator. Multiply the same number to the numerator and denominator. So if I want to get to 22 from 11, everybody, what do I multiply 11 by to get 22? Right, that'll be 2. And what did I say, everybody? Whatever you do to the denominator, you must also do to the what? To the top, to the numerator. It's just like simplifying, everybody. When it comes to simplifying, you're dividing the same thing out of the numerator and denominator. When it comes to changing the fraction's denominator to get the same denominators on the fractions, you're multiplying the same things to the top and the bottom. And the reason that works is because it doesn't change the size of the fraction. The easiest example that I can give you, so the reason that this is legal and it doesn't do anything bad to the fraction, to the number itself, is because of this. Just take a look, take a look, take a look. If I have a pizza box and I have 1 out of 2 slices, well, everybody, what if I went ahead and multiplied the numerator and denominator by, let's go ahead and say 2, just to mess around. Everybody, 1/2 times 2 over 2, what's that going to be? What's that going to be? 1 times 2 is going to be what, everybody? 2. 2 times 2, that's going to be 4. Again, when we multiply, we just multiply straight across. 1 times 2, that'll be 2. 2 times 2, that'll be 4. So in all, even if you didn't quite understand the math, 1/2 is the same thing as 2 over 4. Let me explain that visually. Let me just take this right over here. And instead of having out of 2 slices, I can just do it out of 4. Everybody, that's still 2 over 4, right? 1/2 and 2 over 4, are those the same exact thing? Do they look the same? Yes. Yes, the denominator just tells you how it's cut. But the actual value of the fraction doesn't change if you are multiplying the same thing on the top and the bottom. I could have made that times 5. I could have made it 2 over 10, or 5 out of 10, excuse me. I could have made it 10 over 20, 50 out of 100, 75 over 150. It's still half. It's still half. And that's it. So coming back over here, help me out, everybody. 6 times 2 is going to be what? That's going to be 12. And then 2 times 11, that's going to be what? 22. Thank you. Now let's go ahead and go to the other side here. Everybody, if I want to get from 2 to 22, what am I multiplying 2 by? 11. And remember, whatever you do to the bottom, you have to do to the top. You have to. So that's going to give us times 11 up top. Everybody, 3 times 11, that's going to be 33. Appreciate you. And then 2 times 11, that's going to be the 22 that we need. So from here, the last thing we need to do is going to be just adding these fractions together, because we finally have the same denominator. That's what we need. Now that we have it, we're good. And remember, when it comes to adding fractions, we simply add across. Everybody, 12 plus 33 is going to be what? 45. Now, do we add the 22 and 22, or do we keep it the same? Do we add the 22 and 22, or keep it the same? That's right. We keep it the same. Because if you think about it, everybody, you're saying, hey, I got 12 out of 22 slices that my box holds. Here we got 32 out of 22 slices. That doesn't make sense, but whatever. And then we add those together, and we were basically saying, hey, we got 45 out of the 22 boxes, or 22 slices in a box. So we definitely have more than one box. 6/11 is my birthday. Hey, that's awesome. That's my girlfriend's birthday too. So with that, let's go ahead. That's right. C is going to be the answer. C is going to be the answer. So from here, let's pretend that I wanted to give the answer as a mixed number. Okay, let's pretend that I wanted the answer as a mixed number. How would I do that? How would I do that again? Can someone explain to me how I would do that again? Indy says divide. Divide the 22 into 45. And yes, this is part of arithmetic reasoning, because word problems can have you work with decimals, fractions, negatives, percents. And this is part of the fundamentals that you need to earn and learn to be able to handle word problems. So this is a pure math class that's going to help you with arithmetic reasoning in the long run. Right, so let's go ahead and divide, guys. Let's go ahead and try this out then. So let's turn that in right over here. And that's going to be 22 into 45. Everyone, how many times does 22 go into 45? That's going to be twice. Great. So we have a whole 2 right there. Everybody, 2 times 22 is 44. 45 minus 44 is 1. So this is, again, your remainder. That's your remainder. And so your final answer is going to be a whole 2, because 22 goes into 45 2 whole times. And then we have 1 over 22 remaining. So 45 over 22 is the same thing as 2 and 1 over 22. Does that make a little more sense for anybody out there? Again, just practicing all of that at the same time, does it help you see things a little more clearly than before? Yep, I got you, Lewis. Cool. Good. Sweet. So with that, let's go ahead and allow you to try this one out yourself. So here, 3, 2, and 1. Go ahead. Try this one out. And I'm going to give you a minute and a half to try it out. So let me go ahead and set this timer up. Cool. The timer started, and I'm going to show it next to me right here. So give it a shot. I'm going to move myself out of the way. Try to practice as quickly but as confidently as you can. Use those notes, and we'll be back. And two, one, and time. All right, so what do you have? What do you have? Okay, yeah, put those answers in, guys. No shame at all, man. We want to try our best. And again, whatever answer we get, whatever it leads to, we're here to grow from it. So we're good. All right, so let's give it a shot here. Everybody, when it came to, again, that thing that we saw in the previous problem where we needed the same denominator when adding fractions, what's the other operation that needs the same denominators as well? Right. Subtraction is the other one. Subtraction is the other one. Okay. So let me zoom in a little bit here and let's solve this and really do it confidently. So the first question you want to ask yourself is simply put, I'm subtracting fractions. The rule is you have to have the same denominator. Do we have the same denominator? Yes or no? Right? No, we don't. We absolutely don't. So the next question I'm asking is, well, what is the common denominator going to be? And again, whenever you're stuck or don't know what to use, you can always, always, always multiply the denominators if you're not sure. So 2 times 4 would be 8. And you can use 8 if you want to, if you wanted to. But again, it's always helpful to get to the smallest number that you can that they can both go into. That way you're avoiding the extra work at the end. What I'm talking about is the answer is 4. You can actually use 4 as the common denominator because, everybody, if you notice, one second, let me just let Michael in. But if you notice, 2 and 4, isn't it true that 2 times 2 can give you 4? Right. That's true. So instead of finagling with both numbers and then figuring out what it's going to be, if you notice that one of the numbers can go into the other one to get the same denominator, hey, we're good. We're good. I'm just going to multiply this one here. I'm just going to multiply this one there. That fraction on the left, that's the only one I have to modify because 2 can go into 4. And because of that, boom, we're good. Do our math. Everybody, 2 times 5 is going to give me, hit me with it, that's going to be 10. Thanks, Joseph. And then 2 times 2 is going to give us, right on, nice and easy, minus 9 over 4. And then from there, bam, we're going to handle business. 10 over 4 minus 9 over 4 gives us what, everybody? 1 over 4. And there's our correct answer. So remember and remember and remember, we have got to set our foundations up. Practice as much as you need to with your notes, but there's going to have to come a time where you stop relying on those notes and start progressing to working towards speed. Start with understanding, comprehension, and confidence that you understand it. Then once you have confidence, then you go for speed. Do not try to go for speed before confidence, because I would never have any of a student driver that I would ever teach in my life. I would never put them on the highway before they're confident with driving. So remember, confidence first, confidence that you know how to do the basics, then learn how to speed up the process. if that helps you in your own study. That's what your mom did. Remy, well, you're still alive. I'm assuming that you are whole since you're trying to enlist. And we're going to leave that at that. So next up, go ahead, my party people. I'm going to give y'all a minute on this one here. Starting the timer now. And that one's time. So this one shouldn't have been much work at all, to be honest with you. But we still want to go over it just in case we need to just double check our reasoning. So with that, we have 4/7 plus 2/7. So everyone, we are adding. So we have to follow the rule. We need the same denominators. We do. So we can just straight up add 4 plus 2 is 6. So that'll give us 6/7. We have the same denominator. So we're good. Yeah, I'm glad that you see that this one's easy. I'm glad that you feel that way because you now have that foundational mastery when it comes to adding and subtraction. Cool. So let's go ahead and keep moving then. Let's keep it moving. All right, go ahead. Multiple ways to solve. So go ahead. I'm going to give you the minute and a half here. Remember, everybody, we have ourselves here the same numerators. So this one should be pretty easy. This one should be pretty easy. We have the same numerators. We're good. And that is time. All right, let's go ahead and check it out here. What do we have? Again, we have the same we have the same numerators. So everybody, because we have the same numerators, we're able to just add them straight up, right? We have the same numerators, so we can just add them straight up, right? No. What are you guys doing? Paying attention? Okay, yeah, that's correct. We need the same denominators. If we have the same numerators, nobody cares. Nobody cares. Because you could be saying that I have 2 out of 3 slices of pizza in this box, and I have 2 out of 4 slices of pizza in this box. Those slices are not the same. Yeah, you got 2 here and 2 there, but those 2 are different 2s. These 2 and the 2 out of 3, those are huge slices. The 2 slices and the 2 out of 4, they're smaller. So again, that doesn't make a difference at all. You have different size slices. You need to have them the same size. So let's get into it. We don't have the same denominator. We got 3 and we got 4. Everybody, we need the same denominator. What could 3 and 4 both go into? What could 3 and 4 both go into? And when in doubt, multiply the numbers together if they're small enough. 3 and 4, they're one number away. So it's likely that you're not going to be able to find a common denominator unless you multiply them together. Yeah, and that would be 12. So to get to 12, everybody, what we would see here is for 3, we multiply by 4 on the top and the bottom. And for the 2 over 4, we multiply by 3 on the top and the bottom. So let's get it done. 4 times 2, hit me everybody. 4 times 2, that'll be 8, appreciate you. And then 4 times 3, that'll be 12 as we knew, so we don't need to really dabble in that. But then we have 2 times 3, that'll give me 6, thank you, Indy. And then we have ourselves 4 times 3, which is 12, and we're good. So once we're here, we still have 50 minutes, we're good. So once we're here, now we can add freely, we're set, we're good. 8 plus 6, everybody hit me up. What's that going to be? That's going to be 14. And again, we keep the same denominator. That'll be 12. Now, everybody, we got 14 over 12, but there's a problem. I don't see that answer there. If we know we did the work right, what's the one thing we need to do then? Simplify. If you know you did the work right, but your exact answer isn't listed for fractions, chances are you just need to simplify. Chances are. 14 over 12, you can simplify that because 14 and 12 are both divisible by 2. They're both even numbers. So here I'll divide by 2 on the top, divide by 2 on the bottom. That's going to give me 7 over 6. And we actually see that there with choice A. No worries there. Hey, now we learn, right? We learn those lessons. Yeah, you may have gotten C if you would have just added them straight up with the mistake being made. That's why I put it there. Tweaking because you got it right or tweaking because you got it wrong? Oof. All right. So with that said, my party people, because you got it wrong, no worries. Hey, we'll try again. So that's essentially going to be it for the guided warm-up for adding and subtracting. We're going to get into multiplying and dividing now. But everybody, how are we feeling in terms of our confidence? On a scale of 1 to 10, with 1 being you're still not confident at all, you are forever hating math, or 10 being, man, I feel like I've taken away a lot from here and I can't wait to practice. Good. Thanks for being honest. 51 out of 2. Funny. Harris, I hear you. 8, but still forever hating math. That's the only reason I'm not giving it a 10. I got you. 100 out of 100, which is 10 out of 10. Appreciate you, Gio. Moesha, thank you. Jairus, thank you. Jocelyn, thank you. All right, cool. So with that said then, cool. Let's get into multiplying fractions. And I promise you in this part of class, even if you were bored, you guys are all still here, which is honestly awesome for me as a teacher to see that every single person has stayed in class. But now we're going to move into multiplying fractions. And I promise you in this part here, all the voodoo magic that we're going to do, I promise you that you are going to learn how much or how easy it is to save time if you know what you're looking for or if you know what you're looking at. And this is where experience trumps everything. When you have enough experience with something, seeing these shortcuts is natural, it's clear, it's not even a question, it's second nature at this point. So let's explain the traditional way of multiplying fractions again. The traditional way was, again, this is traditional right over here. So the traditional way was, hey, let's go ahead, multiply the numerators, multiply the denominators, then we simplify. Everybody, there's a much, 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 much faster way, and that's going to be simplify first, then multiply. So same steps. Simplify first, but then multiply is actually so much easier. Let me show you. First example, right over here. I'm going to show you 4 over 9 times 15 over 14. First thing I'm going to do before I actually teach you is I'm going to give you a minute and a half actually to do all 3 of these with the notes that I gave you. Remember the notes are, hey, multiply the numerators, multiply the denominators, and then see if you can simplify. I want you to see how long this might take. Go ahead, give it a shot. Timer, let me put it to a minute and a half. You're getting a little bit of a head start. So there you go. Timer has started. And let me pull it up right here. Again, just to prove a point here. Go ahead. All right, and that's time. So my first question is going to be this. How many of these were you able to confidently get through? How many of these were you able to confidently get through? That's the main question there. Okay, so a lot of us said one in the beginning, then all, some twos in there, none, two, none, meh. I'm gonna take a meh as a none. Two, three, made it after simplifying the second one. Okay, so it looks like the majority of us weren't able to get all three done. And I didn't even ask if you were able to get all three done confidently and guaranteeing that you know you're right. So here's the thing. Something like this, something like this with enough practice, you should be able to get the entirety of all three of these problems done 40 seconds, 45 seconds maybe. You know, it should maybe take you 15 seconds each, maybe, to get this done once you are, once you have the ball rolling. And let me first show you the time consuming way. Then I'll show you the quicker way, starting with number one. So with number one, let's go and get into it here. When we're multiplying for number one, 4 over 9 times 15 over 14. Okay, what we're going to do then is take the numerators. We're going to multiply those. Everyone, what's 4 times 15? Help me out. Oh, yeah, for sure we're going to have more practice on this. So, okay, that's going to be 60. Perfect. So, if you didn't know, we'll do 15 times 4 right over here. 5 times 4 is 20. 1 times 4 is 4, plus the 2 is 6. So, 60. So, we're going to have 60 right there. Then in the denominator, we have 9 and 14. We're going to multiply those together. Everybody, what's 9 times 14? And if you didn't know, no worries. We'll do it right here. You got 126. Sounds good. 4 times 9, that's going to be 36. 1 times 9 is 9. Carry the 3 is 12. So we'll have 126. Cool, we're good. And so that'll be 126 right there. Okay, great. You did it. We made it. We're here. What's the big question? Right. We got stuck on simplifying. Joseph, I agree. Anybody who's doing this for the first time might be doing this and saying, hey, I got 60 over 126. Great, awesome. But what number goes into both 60 and 126? And so if you don't know what that is right away, you might be able to say that it's 6 with some practice. But even if you're relatively new to this, it's not going to be fun to try to do that. So we might first be able to say that 2 can go into both. So let's try that out. We can divide by 2 on both of those. Everyone's 60 divided by 2 is what? That's going to be 30. And then 126 divided by 2 is what? 63, because 120, 60, 6, 3. So 63. And then from here, this is where you might notice that, oh, wait, here, maybe we can divide out a 3. Maybe we can divide out a 3 now. So let's go ahead and do that. So with that, 30 divided by 3 is 10. Thank you. 63 divided by 3 is 21. So our final answer here is 21. Okay, 10 over 21. Awesome. We can do this faster. That took a long time. We can do it faster. Let me show you how. This is where I'm going to set you guys up to get your minds blown. This is why it's worth coming to class, to see the common things done in a much, much faster way. So let me move this over here. This is going to be very important. And I want everybody to remember these two numbers here. I want you to remember right here when we divided by 2 on the top and the bottom, and we divided by 3 on the top and the bottom. Everybody, do you see that there? You see the divided by 2, and you see that we divided by 3 to simplify. Just make sure that you just say yes to confirm what your eyes are looking at. Okay, cool. I am not some magic trickster. Like, no, this is going to be legitimate math. Just take a look at both of those numbers. They're going to come right back to play right over here. Watch. Before you multiply, that was the rule that I was talking about right over here. Instead of multiplying, then simplifying, let's try simplifying, then multiplying. Here's what that looks like. So 4 over 9 times 15 over 14. Everyone, you might be saying, hey, coach, what do you mean? 4 and 9, they don't share anything. 15 and 14, they don't share anything either, coach. What do you mean? What I mean is, everybody, when you are multiplying fractions, because you're going to multiply on the top with the top, and the bottom with the bottom, when you simplify, it doesn't matter if this one isn't above the other denominator. It doesn't matter. Because at the end of the day, this is what it looks like. 4 times 15 over 9 times 14. That's what it's going to look like. And so when you look at it like that, remember, everybody, true or false? 4 times 15 is the same as 15 times 4. True or false? 4 times 15 is the same as 15 times 4. Yeah, that's true. So all I'm setting you up for by saying these things that you already know is that when you're simplifying, when you're multiplying fractions, both of these are on the top, both of these are on the bottom, as you can see. So you can simplify the 15 and the 9? Absolutely. Everyone, what goes into both 15 and 9? 3. You can divide a 3 from the top and from the bottom. Whatever you do to the top, do to the bottom. We were able to do that. And again, this only applies when you're multiplying fractions. Divide by 3, divide by 3. Great. When that happens, everybody, what do you get? What do you get? That's what's going to be up top. 15 divided by 3 is what? 5. Yeah, that's going to be a 5 up top. And that's going to be a 3 on the bottom. What else can we do? Well, we have the 4 up top and the 14 on bottom. Everybody, what can you divide from 4 and 14? You can divide a 2 out. Absolutely. I can take a 2 out by dividing from the top and the bottom. Look at how much simpler this becomes. 4 divided by 2 is 2. 14 divided by 2 is 7. Now that we're done simplifying first before multiplying, allow us to try multiplying now. Everyone, 2 times 5 is what? That's going to be 10. Everyone, 3 times 7 is going to be what? 21. If we simplify before we multiply, we can get the same result much faster with the possibility of making many less mistakes. You risk less because you stay dealing with smaller numbers as opposed to generating these huge numbers and then running the risk of not knowing how to simplify right away. That's the advantage you have here. Same process, but when you do it backwards, when you do this step first and then the other, guess what the advantage that you give yourself? Again, dealing with smaller numbers, allowing you to work faster. Does that make a little more sense, everybody? Perfect. And let me answer some of these questions here. Let me zoom on out so I can give you guys the perspective you need. And then I'm going to do this for you here. That way you can just split it up there. So I'm going to let you take your screenshots, and I'm going to read through the comments here to make sure that I didn't miss anything here. Hey, coach, from what you're saying, can you rewrite 15 over 9 times 4? Absolutely. Yep. Nana, yeah, exactly. That's exactly what I'm saying. Couldn't it be 5 over 7? I mean, it was, Chad, it was right over here. And then we went ahead and did the multiplication there. So hopefully that answers that there. Let me see. Wow, I did not know this method. There you go, Princess. I got you. And Alejandro, I'm glad you recognize how awesome this is. So let's go ahead now and see what we could have done here with the second one. 3 over 5 times 15 over 19. Well, guess what, my party people? Instead of doing 3 times 15 to get 45, 5 times 19 to get what? That'd be 95. So you would have 45 over 95, and then you'd have to simplify that. Why would you want to do all that work? Instead, you can notice, hey, 15 on top, 5 on bottom. Everybody, what can you divide out of both 15 and 5? You can divide a 5 out. You can divide a 5 out of both the top and the bottom. And remember, everybody, even if you don't simplify it fully, even if you just do one piece of simplification before you actually multiply, you still give yourself a million times of an easier problem because you're dealing with smaller numbers. 15 divided by 5, that's going to be the case there. Divide by 5 there, and that's going to give you the same 3 and 19 are going to be where they were, but the 15 divided by 5 is going to be 3, and the 5 divided by 5 is 1. And now that we're here, what do? We just multiply straightforward. 3 times 3, everyone, will give us what? That's going to give us 9. 1 times 19. Man, this is the hardest question of the day. 19. Look at that. Cool. Anybody here get number 2 done and simplified and saw what I did here and said, why did I do what I did? So the point here again, everybody, we have to be willing to look for ways to do the same thing in a more effective way, in a potentially more effective way. This is just one of the many things you can learn to make your life so much easier when it comes to calculation. Let's go to the last one here. Let's finish this one here. Immediately what I would notice is, you can simplify the 10 and the 12. You can also simplify the 10 and the 5. You can simplify them both. Absolutely. That'll still work. If you want to go ahead and try simplifying, then simplifying again before you multiply, sure. But you could also just simplify all at once. Here's what I mean, everybody. Here's what I mean. I know that 10 is divisible by 5, and 5 is divisible by 5. Everybody, what do I also know about 10 and 12? What can you divide out of both 10 and 12? 2, not 3. 2. 10 can be divided by 2. 12 can be divided by 2. 10 cannot be divided by 3. It cannot. So from here, I can divide 10 by 2 as well and divide the 12 by 2. When I do all of that, it's all good, Jamila. It's all good. So when you do all that, everyone, we're still not done simplifying, but I'm going to, just catch my breath because I don't want to do too much. That 9 stays where it is, but everything else kind of got changed around. Everyone, 10 divided by 5 divided by 2, what's that going to be? Think about the math in your head, everybody. 10 divided by 5 is 2. Then divided by 2. 2 divided by 2 is 1. And so I hope you see that if you multiply by 5 and multiply by 2, that's multiplying by 10. If you divide by 2 and you divide by 5, that's the same as dividing by 10. 10 divided by 10 is 1. Then, everyone, the 5 divided by 5 over here, that's going to be 1. The 12 divided by 2, that'll be 6. So now I have the easiest math problem ever. I got 9 times 1 over 1 times 6. That's going to make my life so much easier. Even though I'm not done simplifying, I have a much easier problem now. Now all I have to do is figure out what goes into 9 and 6. Yep, we can divide by 3. And we're set. And we're set. 9 divided by 3 is 3. 6 divided by 3 is 2. So that'd be 3 halves or 1 1/2. Either way. But I want to show you that right there. So is that making a little more sense, guys? Is that making a little more sense? That you absolutely can simplify before you multiply. And I think I missed a question. I got you. I'll go back to that. Why did you divide 2 instead of 3? You could have done either way. Yeah. So Philly, you could have done divide 3 from the 9 and divide 3 from the 12. Absolutely. You still would have got to the same answer. Yep. So that was just preference. You can do whatever you want as long as it works. As long as you are able to simplify in that manner, you can go in whatever order you want. So hopefully that makes sense, Philly. All right, good. Are you guys ready to try to do another round of this, a timed practice? You guys ready? Let's go. Let's go. Let's go. Let's go. All right. So let me go ahead and get the timer up. I'm going to give you all a minute. And actually, would you guys prefer 2 minutes or a minute and a half? Quick. First person. 2 minutes. All right, cool. All right. So for right there, there's the timer. All right. Let me get the timer up, get my face out of the way. Here's the guided practice. Let me zoom in a little bit on it. And go ahead. Start now. All right, and that is time. So let's work through this one fairly quickly. Let's make sure that we have had the chance to get this done and confirm or reaffirm what we understand to be true. So move that over. I was eating some nerds. So with that, here we go. Always tiring at the end of a Monday night, but we got this. So 3 over 5 times 1 over 3. Everybody, what do we notice about the top and the bottom? What do they both share that we can clearly see plain as day? Nana, thank you for the comment. But yeah, so that's going to be 3. 3 on the top, 3 on the bottom, and we're good. We can just go ahead and cross that out, man. Crossing it out just means that we're leaving a 1 in its place. So this ends up becoming 1 over 5 times 1 over 1. And you're looking at that and you're like, well, if I'm multiplying by 1, well, then the answer is just going to be 1 over 5. There's no need to figure out how many times 3 goes into 15 if you did it the regular way. I mean, obviously, given how easy that was, you could have done it either way. Could have done it either way. But notice that you don't have to multiply to then come back down if you just start by simplifying to begin with. Next up, we have 3 over 2 times 2 over 3. This one you might be really, thankful that, well, you can take away the 2's. You can divide out the 3's. So that'll just end up becoming 1 over 1 times 1 over 1, which is just going to be 1. Anything divided by itself is 1. So that'll just be 1. And if we look at the last one, right over here, 4 over 3 times 3/5, this will be a quick one as well. You can just cancel out the 3's, and that'll just be 4 over 5. Because what it would end up being is 4 times 1, 1 times 5. 4 on top, 5 on bottom, and we're good. Exactly. Even if you're just looking at it and you can see that these numbers are shared, boom, it saves you a ton of time, even on the easy problems. Does that make a little more sense for everybody? Is that solidified now in terms of the importance? Good. That's what I'm going for. Can't ask for anything else. Perfect. That's what's up. So with that, we got another one coming up. 3, 2, 1, and hit it. We got another one here. 2 minutes. Let's go. We should have plenty of time to get into division as well. You guys are doing great. Three, 2, and 1. My party people, go ahead and put those. Well, no answers here, but how did you do on this one? Because this one's a little different, given that we have whole numbers instead of actual fractions. But you tell me, did that make a difference for you? Were you still confident in being able to do what you needed to do? There you go, over. Appreciate you. Congrats on passing. Let's try it out, guys. Let's see what's up. Congrats. Again, I'm passing go over, but with that, let's get into it here. We have 9 over 7 times 2 over 3. Go over. If you haven't had the chance to shoot me a text, go ahead and shoot me a text. I want to give you a more personable congratulations and follow up with you. So we have 9 over 7 times 2 over 3. Everyone, we take a look at this and we're saying, hey, man, 9 and 3. 9 on top, 3 on bottom. We can definitely split that. We can definitely. Thank you for showering the love. There you go. So here, we have 9 divided by 3 and 3 divided by 3. And once we do that, again, this becomes a much simpler question. We have ourselves here. That'll be 3 up top, 1 on the bottom there. and the same numbers stay from before. Now that we're here, it seems that we have this in simplest form, so we're good. 2 times 3, that's going to be 6. And then 7 times 1, that will be 7. And we're set. We're good. We can move forward. Any questions on this one, guys? How are we feeling? Good. Good. All right, next up, we have 2 times 1 over 8. So everybody, in case you forgot this one essential fact, it's this. If you have a whole number, remember that a fraction is just the top divided by the bottom. So if you have a whole number and you're a little confused on that, remember that you can just write that as over 1. 2 divided by 1 is 2. So 2 over 1 is the same thing as 2. It just makes more sense in general to write it as just 2. But for the sake of multiplying fractions, it'll help you see that what we're really doing is numerator, denominator. That's really what's going on. The whole number multiplies into the numerator. And so if you see it that way, well, then you'll be able to tell that, hey, we can simplify the 2 and the 8, giving us 1 over 1 times 1 over 4, which is the same thing as just saying 1 over 4. And again, this, you can probably do that in your head. You don't need to see that, but I will show it to you just to make sure you see what the procedure kind of flows through. So next up, we have 3 multiplied by 3 over 4. Cool. So don't get confused. Some people might think that we can just simplify these. That's not the case. Again, 3 is the same thing as saying 3 over 1. And so with that, once we're here, for the first question, sorry, Nana, let me go ahead and just check that out. Sorry about that. Nope, 6 over 7. 6 over 7. So here we have 3 over 1 times 3 over 4. What we'll do is multiply straight up. 3 times 3 is 9. 1 times 4 is 4. And there it is. There's our answer. And if they ask you to show it as a mixed number, then you would do it. So to answer your question, Kai, showing an improper fraction is improper is not incorrect. It's just improper, but it's not wrong. It's not wrong unless the answer choices tell you that you need to use a mixed number. That's the only way. That's the only reason. Yeah, cool. Gotcha. So now what we'll do here with 9 over 4, what we'll do is we'll go ahead now and divide the 4 into the 9. 4 goes into 9 2 times. That's the whole number. And then we subtract 2 times 4, which is 8. We have 1 left over. And that's going to be the remainder. 1's going to be the remainder here. So we end up having 2 and then 1 over 4. So those are both correct. Those are both correct. 9 over 4 and 2 1/4 both are correct. And Olivia, same thing up there up top. What we just did was, hey, we have the 2 up top, 8 on the bottom. Just divided the 2 out of both to give you 1/4. 2 divided by 2 is 1, so that's why we have that 1 over 1 here. But at that point, you can just ignore it because 1 divided by 1, when you're multiplying a fraction, it's the same thing as multiplying by 1. So I'm glad you guys are asking about more of these. I'm really, really happy that you want to take part in more practice. So because of that, I want to take a moment to show you how to find more practice. We have more recorded lessons. We've got worksheets with hundreds of problems in each worksheet. We've also got guided practice with video solutions, taking you through, just like I am here. And then you also have what are called speed drills. Speed drills allow you to practice this under a timer to show, just like we're doing in class, that you understand what you're doing. So I want to just take a brief moment to show you how to access that on the website, especially for those of you that are in the program. For the simple reason being, I got to take care of y'all. I got to make sure you know how to get things done, because if you don't, then that's on me. So can anybody see the screen behind me? Yes or no? Cool. Sounds good. So this is all you got to do. Once you log into the website, if you're in the program, great. All you got to do is log in. Once you log in, you click Math Basics. When you click Math Basics, I'm going to take you to this over here. This is your Math Basics dashboard. There's a video here showing you exactly how it works if you want to play that. But it's going to show you the 7 essential units that you need to master before going into arithmetic, reasoning, and math knowledge. The 4th one, right there, Unit 4, fractions. So all you have to do to get to there is scroll down to Unit 4, fractions, open it up, and this is everything you have: lessons, worksheets, guided practice, speed drills. You have all of that for this. Simplifying fractions, turning improper fractions to mixed numbers, converting fractions to decimals, converting fractions to percents, adding and subtracting, multiplying and dividing. Like, that's what makes the math basics so powerful. It's because we give you all of the opportunities to master every bit of it. That way, when the ASVAB does throw that weird question at you, you're ready for it, as opposed to freaking out because you've never seen them word it that way in your life. Like, this is the difference maker. And so when you click, let's go ahead and say, we're looking at adding and subtracting fractions like we're doing today. You have everything available to you here: lessons, videos, guided practice, worksheets, and then there's a speed drill. So if you want to practice like you've been doing today, this is the speed drill for adding and subtracting fractions. You have 10 questions, 10 minutes, which basically is 1 minute per question, which is a long time. And you need a 90% to pass this. And every time you reset it, you have new questions. So it's not like you're going to be seeing the same ones. So once you click ready to start, boom, evaluate the expression, take care of that, you do your business, and then, all right, cool, blah, blah, blah. I'm just going to put random answers. And here you even get to practice with negatives as well. And so you did your thing. I'm going to practice all the way through. Click submit. Okay, I failed, got them all wrong. But the great thing is you can go through the feedback report and it'll tell you what the correct answer was every single time. And you go all the way through. So that's the great thing about this, my party people. And when you're ready, you click retake, you start over again, and you keep going until you get it down and you know you've got it down. My party people, is that exciting for you? Is that something that you are going to promise to practice on your free time? Good. You got to make sure you practice. Again, like, this is the difference maker, guys. This is the difference maker. I built this program out. There's over 18,000 practice questions in the course, on all the courses combined. And when it comes to the arithmetic reasoning, you have step-by-step solutions for all of those. You have every single resource you could probably ever need. And all you have to do is follow the plan. Follow the plan and you'll succeed. With the math, start with the basics, move on to the courses for AR and MK, then take practice tests while you get ready for test day. It's that simple. All you got to do is sit down and get to work. And there's a similar plan for English and general science. So it's all there for you guys. Just take the opportunity that you have if you're in the program. And if you're not, stay till the end of class after we do dividing and we'll see what's up. I got you, Joseph. I'll walk you through that. I got you. No worries at all. So let's go ahead and get into this here, my party people. Now what we'll do, since it is 7:47, you guys tell me, would you rather me, with the last 5 minutes, try to get into dividing, which probably wouldn't be the best, or do you want to just do more timed practice for multiplying, adding, and subtracting? Because you timed, more practice. Cool. Yeah, I agree, because that'll give you more chances to really drill in what you have. So with that, let me get us all the way over here. Let me skip all these. Actually, no, we'll do these speed. We'll go ahead and absolutely do these for speed. So let me get my face out of the way, put the timer up, and I'm going to give you, let's go ahead and say 45 seconds per question, okay? 45 seconds. So number one's coming up. 3, 2, and 1. Let's go. There will be, Deborah. I got you. All right, time's up. What do we have? Yep, correct answer in this question is going to be C. Get ready to take a quick screenshot so I can show you how this is done. 1 plus 7 is 8. 8 over 4, that's 2. Moving on to the next one. 3, 2, and 1. You got this, guys. Keep it up. Come on. We're good. This one, I'm going to give you 10 seconds. 9, 8, 7, 6, 5. Come on. And answers, go. Yeah, anything subtracted from itself is 0. We know that. We know that. Just got to make sure to keep you on your toes. Next one up. 3, 2, 1. Let's go. This one's going to be a 20-second problem here. 20 seconds. Don't give away the answer yet. Three, two, one, hit it. Bonus. Give it to me as a mixed number. Bonus. You have 15 seconds. Give it to me as a mixed number. And 5, 4, 3, 2, 1. 1 3/5 is the answer. 1 3/5. The answer is C. And 1 3/5 is the answer. Next up, let's try to give you this one. Here we go. 45 seconds. Four, three, two, and 1. Correct answer here will be A. 7 over 6. Up next, 3, 2, 1. Let's hit it. Don't share those answers. We got 10 seconds left. Not yet, not yet. 2, 1, and time. We have 1 plus 1 over 7. Yes, the answer will be C. And as a bonus, that would be the same as 1 1/7. If you don't notice, that's basically 1 attached to 1 over 7, which is the exact same thing. Next up, hit it. This one's going to be very, very quick. But this one here actually was an error. This is the error that I found earlier. Don't want that one. This is the one. Timer starting now. Three, two, one, and time. Answer is A. Answer is A. 5 over 8. 5 over 8. So for this one, to get 5 or 8, here's what you got to do, my party people. Long story short, we notice that, hey, 2 is the same thing as 2 over 1. We are subtracting, so we need the same denominator. And because of that, we see that 1 can go into 8. So I'll just go ahead and multiply by 8 on the top and the bottom right here. After doing that, my party people, we're good. Because 8 times 2 is going to be 16. 8 times 1 is 8. So you have 16 over 8 minus 11 over 8, giving us 5 over 8. And we're good on that one. I want to give you one more here for multiplication and division. So let me go ahead and find one here. All right, so let's go ahead and give it a shot. Let's go with this one. I'm going to give you here a minute, 45 seconds to do all three. Glenda, I know I tried to go over one of them, couldn't go over both, but here we go, my party people. We have a minute and 45 seconds for all three of these, and this will conclude today's class, and we'll talk about what you can do moving forward to keep raising your score with that program. Go ahead. And time is up. So let's go ahead and finalize this. Let's see what we got going on, my party people. Let's see what we can do here. And remember, guys, the point of this was to see how well you do under the current circumstances. So even if you weren't feeling like you were able to get all of these done confidently, that's not the point. The point is, did you improve? Have you improved? Do you feel any sort of confidence? Do you understand the steps here a little better? That's really what we want to do. So here, 5 over 12 times 22 over 29. You could definitely go straight up and multiply that across, but no. Better way is to go ahead and just plan out and see if you can have it simple before you go. So here, 22 and 12, I'm going to divide out from both of these 2. And it looks like that's the only thing I can actually truly do because 29 is a prime number. Nothing you can do there. So we end up getting 5 over, that's going to be 6, and that'll be times 11 over 29. So now that we're here, that's as good as we can do. That's as good as we can get. And with practice, you'll know that that's as good as you can get, and you're good. So 5 times 11, that'll be 55. 6 times 29, that'll be 180 minus 6, so 174. And there it is. Your answer is going to be 55 over 174. The math is good, and we're set. And again, that was me doing that in real time. I was just chilling, looking at my phone while the timer was going, and I came back and did this. That's with mental math practice. I don't even practice that much anymore. It just takes enough to get the ball rolling, to get the speed going, and that's it. You never really forget it. You never really forget it. You just got to put in the work. Next up, 11 over 10 times 15 over 14. Immediately here, I noticed that, hey, we got ourselves a 5 that we can divide out. From there, there's really nothing else that we can do, so I'm good. We see that we're going to have 11 over 2, and this is going to end up being 3 over 14. Look at how much easier this is. Now we're just doing 11 times 3, which is 33, 2 times 14, which is 28, and the other way to write this as a mixed number will be 1 and 5 over 28. Sweet. And then lastly, over here, my party people, 4 times 2 over 7. That's the same thing as just multiplying the top. So 4 times 2 is 8 over 7, or 1 and 1/7. And there we have it. So how'd you do? I know I have to go a little quick because class is ending shortly, and I do need to make sure that those who want to get into the program can do so without waiting too long. But how did we do on this one? This page here. 1, none, 2, 3. How many did we get right? Again, the most important part about today's class is your experience. What did you take out of this? Because I do this class, 4 times or 12 times total in a month, and we do this 144 times a year. We do this a lot. But the most important thing is making sure that it's worth it to somebody. And that means you. So I'm glad you guys gave that feedback. I'm glad that we're feeling like we're moving forward in the right direction. So remember, this is part of your Math Basics course, Unit 4. So if you're in the program and you want to practice more specifically on this, there you have it. You have speed drills for every specific thing. Adding and subtracting, you got that. Turning mixed into improper, you got that. Multiplying, you got that. Dividing, you have that as well. It's all in there, and it's worth it, I promise you. We've built this program over the past 4 years. All you have to do is sit down and get to work. Everything is lined up for you. So for those of you that are in the program, keep taking advantage of it. Keep doing the work that you've been doing. Shout out to the 35 plus people who have made it on the board this week. And of course, that board keeps growing. We might need more than one page to stuff all your names on there. So congratulations to everybody who's been working hard and passed the ASVAB. And I also want to just push you guys to keep working hard and pushing forward there. For those of you that are interested in the full program, stay for just a few moments so I can explain to you how it truly works. And then for those of you that are already in the program, we have a class tomorrow for arithmetic reasoning at the same exact time, 2 hours. And tomorrow is all word problems. We're going over random word problems from random units. And I'm going to show you where each problem comes from so you can then go into the course and practice those same exact types of problems as much as you'd like. It's all there for you. So sounds good, Indy. Congrats again to Indy for winning that hoodie. Diop, congrats again for passing the ASVAB as well. Congrats, Chris Lane, Kenneth as well. You guys have done an awesome job. And again, for those of you who are not in the program, let's go ahead and talk about if this is a good option for you. And for those of you who are in the program and you've been in it for more than a couple of days to a month or more, go ahead and leave some notes for the people that are considering the program. You tell them what you think about the program so that way they can potentially make a decision for themselves. Just go ahead if you want to. If not, I'll see you tomorrow either way. But I love you guys and I'll see you tomorrow. So for those of you that are considering the full program, so this is typically what I ask my students. First and foremost, it's this. Number one, if you have test anxiety, if you feel like, when test day is coming up and you get nervous for no reason, or your heart rate just starts racing, or you have to breathe more heavily, just because you're thinking about the test, you're already in a position to possibly do worse because of that nervousness and pressure. Because you need to have an answer for that pressure. And if there's no answer for that pressure, things get harder. Number two, do you blank on word problems? If you're sitting here saying, yeah, I have definitely blanked on word problems, that's the most common form of test anxiety and test struggle. Definitely fixable. Number three, if you feel like you hate guessing and hoping for the best, if you run out of time so often on the test that you're constantly Christmas treeing, you're constantly just saying, all right, C's get degrees, when you have 10 questions left with like 1 minute left. You don't want that. You can train for that, definitely possible. And lastly, if you feel like you're kind of going through this alone, you want someone to kind of walk you through and tell you this is what you need to do, then this will work for you. So if you answered yes to any of them, this program is for you. If you answered yes to 2 or more, definitely you want to consider this. And if you have a test coming up tomorrow or after tomorrow, and you're saying yes to 2 or more, you should probably reschedule. Probably the best move. So really quick, just to make things simple, because it is getting late and I want to make sure you're ready to sign up if you'd like to. If you feel like this session improves your chances of passing, if you feel like more of this could work for you, and if you think that my teaching style matches your learning style, then let's get to work. There have been a ton of students who have come into my program and have passed. Over the past 4 years, 1,500 of our students have raised their score and gotten the jobs they want. And right now, there's over 600 students right now in the program. They're working hard every single day. They're logged in at the wee hours of the night. It's self-paced. You don't have to show up to all the classes. And that's the great thing. The classes are recorded for you, so you can study from whenever, wherever you're good. But the main plan is this. These are the features that are listed, and you're going to watch, practice, and master. But again, like I told you earlier, it's super simple. For the math basics, move into the specialized AR and MK courses, and then take practice tests. That's simple. It's lined up for you. For the English, you start with your study guides, you go into those specialized courses, and then you take practice tests all the way until you're ready to take the actual test. And that's it. And then you have the live class component where you can go ahead and attend the classes to continue getting refreshers, or you can watch any of the 500 plus recordings that are in the website. I know it says 450, but that was last month, so it's updated now. And then on top of that, you have a progress report that I send to you on a periodic basis. I will be sending out the next one tomorrow if you're in already. And on top of that, you can always text me for help. I'm not that kind of teacher or tutor that disappears. I'm available Monday through Friday, and I text everybody back at least once every day. So always hit me up if you have any questions. I'll have your back all the way. It's that simple. So here's how you're going to sign up. Super simple. You're going to click the link that I'm going to put in the chat box. You're going to pick a plan, and you're going to sign up. It's very quick, very easy, and I'll show you exactly how to do it with the screen behind me too. So go ahead, look in the chat box right there, and I also included the coupon codes. For the monthly, you can use the code GET10 for 10% off every month. You can also get $150 off my full year, and that's going to include, again, 12 whole months of everything, and you can get that for 147 bucks. That's going to amount to 144 classes for 147 bucks. If you do the math, well, you're paying close to $1 a class, and that doesn't even include all the courses, all the video solutions, all the recordings, all the help you can get via text, all the progress reports to help you get there. Yes, it's insanely cheap, and it's because we've learned how to do things in bulk, how to help many people at once. And that's why I don't do one-on-one tutoring. And so with that, you can get the lifetime as well. You can get $200 off the lifetime for $297, down from $497. There are the details for you in the chat box. I'm going to put the same details here. Boom, in there for YouTube, my party people there. But just to show you what it looks like back here, let me go ahead and just show you how to sign up from my end. Right here, sign out. And I'm going to walk you through exactly how to get this done. So if you're stuck or if you're confused, go ahead and just take a look behind me. This is what the website looks like, nice and easy. And what you would do is you would go ahead and click recommended, join all access program. But with the link that I put in the chat box, this is what you'll see. If you want a little video to show you how it all works, what's going on? There's the video right up there. You can go ahead and see me explain the program from start to finish. Nice and easy. Or you can go ahead and scroll down and you can kind of see all the features and everything it comes with. But when you're ready, click right there. Sign up now and raise your score. Takes you all the way down to the bottom. There are the 3 plans. Pick one of them. Monthly, year, lifetime. That's it. You click, subscribe. It's going to have you make an account. You just got to let it load for a second. And then you'll be set. Cool. Sign up to Duran Learning. First and last name. Get everything done. And once you're there, pause that. And once you're done signing up on the form, you go to the payment page and you're done. Your account's going to be created. Everything's going to be put into your account. You'll get a welcome text, a welcome email. Make sure to read both of those. Go through the checklist, and you're set. Everything is lined up for you. So what I'm going to do now is I'm going to go ahead and take a couple of seconds here to just answer some of the common questions that I see in the chat box. And from there, it's up to y'all. So I'll put the instructions back here. Click that link, click raise your score, pick a plan and sign up, and you're good. Most common question I get is the subscription. No, it's not a contract. All you have to do is cancel whenever you're done, just like Netflix or Hulu. You're good. Super straightforward. Yep, Joseph, take your time. Join on Friday. You're good. You're good. Take your time. And I know I saw 3 people already sign up. Yep, for the 3 people that already signed up, just make sure to check your email and text message. That way, you know exactly how to get started the right way. There's not going to be any confusion, and you'll be in a position to succeed. Yep, that's right. Once you sign up, it's the math basics. Yep, because the plan is for math is going to be math basics, AR and MK courses, and then you go into the practice tests. So that'll be the exact plan for you. Yeah, so the classes, it's going to be 3 classes per week. So it goes up to 12 per month. So you're going to get up to 12 classes per month. and you can get the schedule to see when all the classes are. But here's the great thing. The live classes, like they're awesome, right? You have a good time, you ask questions, you get answers. But when you're starting off in the program, the live classes really aren't necessary because truly what we go over in the live classes most of the times is arithmetic, reasoning, and math knowledge stuff. But before you can truly be ready to sit in there and be like, oh yeah, you said that, I understand it, 1-to-1. Not like you said it, but I'm not really sure what you're saying. To avoid all of that, the confusion in the beginning, math basics. I guarantee you, when you focus on the basics and then you go into the AR and MK, the progress is literally 5-6 times as fast because the foundation is so strong that you're just seeing how all these foundations are relating to what you're doing. It's the biggest thing. Like, I know it's easy to be impatient with that process, but man, once you stick to it, you'll see those results come like just opening a faucet. So yeah, if you want to upgrade your plan, Zara, just hit me up. I'm always down to hook you up. So feel free, Zara, if you've been in the program for at least a month, with the monthly, we can definitely talk about, using what you've already paid, the discount for sure. Man, I'm glad. Yeah, I'm glad you're seeing that this is possible. I know how it feels, especially when, we come from some of the walks of life that we come from. It's not exactly easy or encouraging to want to succeed in your life, and not everybody's there to support you. So, coming from where I come from, I want to make sure that everybody else out there, if they want to succeed or join the military or get through anything that requires any sort of academic prestige, I'm here to help you out. That's really been my goal. I have a master's degree in education. I went to school for a long time to do this. And it's just been a really fun ride to see people smile as opposed to be worried about their careers. It's been a blessing, all things considered. Joseph, they're all the same plan. They all give you the same thing. They're just different time periods. So the monthly, it's a subscription. It'll renew month to month. You can cancel whenever. The year gives you a full year, one-time payment. The lifetime is a one-time payment, and you get me for life, ever. Yeah, for the future soldiers program, because that assumes that you had a 10 at the very least to begin with. So if you had a 10 to begin with, 2.5 months, perfect. 2.5 months, I can definitely get you there. But you have to be consistent though. You can't just get in and think that it's like magic voodoo. No, it's a little bit for 2.5 months. If you're even studying 3 hours a week, that'll get you there. Oh yeah, you get the same treatment, Joseph. Yeah, you get the same treatment. The only thing that is different, I would say, is if you are in the lifetime package or the year package, whenever I update anything in the program, you're the one who gets it without ever paying anything extra. So if you're already in the year or the lifetime, like let's say I come out with a brand new course or I release another 15 practice tests into the website, because we do put in the work. So for the monthly subscribers that are already in, we don't change their price. But if it's someone who hasn't subscribed yet, they might see a price difference. So if you're in the year and you're in the lifetime and I release something new, you never pay an extra dime. Yeah, Cesaro? Yeah, just hit me up. No, Jairus, I have everything. So I have arithmetic, reasoning, math knowledge, word knowledge, paragraph comprehension, and general science. My specialty is mathematics, but I still teach English, still teach general science. It's all there. These are good questions. And then let me go over here to answer these questions on YouTube. Cool. None there. And I'm going back. So person starting with R, J, M, A, K, A, and M. All of you guys who have signed up and made accounts, again, just make sure to go through the process. Sign up, you're good, but please make sure to read the welcome email and welcome text. Go through the checklist. That is number one most important thing to do when you get started, because it's going to set you up for success the entire time you're in the program. Yeah, and the great thing is, like, you can get a whole month of ASVAB help for less than an hour of what a tutor would charge you. So yeah, like, this is affordable, absolutely. Yeah, Joseph, go ahead and grab it. Either coupon that you want. You can use get 10. So let me go ahead and put it into the chat box for you again. You can use the code get 10 all caps for 10% off forever for the monthly. You can use year 150 to get $150 off the year, or LT 200 to get $200 off the lifetime. So this is a once per class thing, and then it's going to be deactivated at 3 a.m. Eastern or midnight Pacific time. So you still have a long time to consider it. You have like, what is that, 7 hours? You're good. Yeah, you're welcome. I appreciate you. Yeah, just let me know when you're gonna sign up, man. You're good. And just keep checking your email. Keep checking those emails. If you're considering the any of those packages, I mean, just look out for my emails to make sure that the sign up doesn't change. And if you still want me to activate the discount code for you, I might make an exception for you. Just hit me up. Wink, wink. Great. See you tomorrow as well. Yeah, tomorrow's arithmetic reasoning. It's gonna be a good one. Yeah, what's up, Joseph? How do we get a shirt? Sometimes I give them away during class. Sometimes I give away on social media, or you can buy them flat out. 25 for a shirt, 30 for a hoodie. I don't make any money off of them. That's what my manufacturer makes, and he ships them out. It's all included. Jesus, have a good day too, man. I'll see you tomorrow. Hey, you're welcome, man. Thanks for putting up the work. All right, my party people. So I have stayed for as long as I can stay. I am human and I do need to get rest. So you guys have been absolutely amazing. That's right, Joseph. Again, I'll see you on Friday, man. Just make sure to communicate with me if you have any questions at all. I got your back. But everybody, seriously, thank you. Keep putting in the work and time. I'll see you guys tomorrow at 6 p.m. if you're in the program. If you have any questions at all, please take down my phone number. You can shoot me a text anytime. Right here, my number is 567. Let me actually just go over here. My number is 567-698-8867. Again, that is text only. Check the class schedule to see the next class is coming up. June schedule is coming out on Wednesday. So get ready for that. You guys have been amazing, and I will see y'all in tomorrow's class. Ace the ASVAB.